Howdy, so tonight on the workbench I have a hard drive which I'm going to tear down and go through how they work, basically how data on them is arranged and the evolution from where we started with hard drives, basically to where we are now. But before I do that, I'm just doing an update on the black box flight recorder. So after some research, I now know enough about the black box, and a bit of head cramming over the course of a couple of days. I now know enough that I know how everything interacts inside the black box, the data coming in, how it's sort of all put together and put on the tape. I also know how to power it up. I don't have a power supply. I'm going to have to be creative to create one, and I think I'll build a small scale one to test my theory first. It's 125 volts at 115 volts, sorry, at 400 hertz. So I have to construct a power supply to turn it on. I'm aiming to do 2 videos on it back to back. One is the teardown and the power supply repair. The other one is actually interrogating it and reading back its last flight off tape. I don't know how to talk to it yet, so I've just been holding off while I try and find documentation necessary to talk to it. But yes, I actually know now how to wire it up to switch it on, and I also know how I could feed it my own flight information. So if there's no flight information on it when it's interrogated, we'll just put some of our own on it. I'm sure I can come up with something to come up with a very epic looking flight, provided it has tape. Anyway, yes, tonight, hard drive. This being a SATA unit, fairly modern. I've had them for a while. Originally, from a desktop perspective, we had the original 5¼ inch ST504 drives. They had 2 connectors on them, a fairly long connector, which was control, and a shorter one, which was data. Control was chained, data was separate cables, so if you had 2 hard drives, you had 3 cables instead of the 1 now. And the way it worked, you had your drive, which was dumb. Basically, it didn't even know how to step to a particular track. All that logic was in the controller, which is the card that went in the computer to control it. And cards were tied to disks. They're fairly messy because you'd have a lot of different disks and controllers to begin with, and then some controllers would support multiple types of disks and so on and so forth. Then came IDE. IDE is a bit of an interesting little cookie. Basically, they took that controller card and put it on the disk. And the 40-pin connector on the back of an IDE drive, those pins actually match up to the original ISA socket pins. I don't know if I've got an ISA board here. I have an ISA card. That's close enough. So pins on the back of an IDE disc would actually match certain signals that you'd see on these connectors. And indeed, the first IDE disc controllers were nothing more than a card with a connector here that wired straight into the pins to connect it to the computer. That's why it was called AT attachment, ATA. It evolved over time to get faster and a few other things. You needed more chips to talk to the newer discs, and you couldn't wire it. And then PCI came along and just made it even messier. Basically, IDE to PCI was effectively an ISA bridge. Yeah, anyway, we're going to pull this one apart and go through all the various bits of it. So, I shall pull it apart. Now, before I continue pulling it apart, this is a multi-platter disc. So, there's 1, 2, 3, 4 platters in the stack. So this is one of the 2 bad mojo things I'm going to talk about. I've seen hard drive repair information and videos where the spindle motor's given out or completely seized, so this just doesn't turn, of multi-platter discs where the advice is to very carefully remove the spindle clamp, get the heads out of the way, and remove the platters. Now, that's a really bad idea, because those who have been around discs long enough know that the old method of accessing discs is cylinder head sector. Obviously, head is obvious. Well, not anymore. That I'll go into later. A cylinder is in place of a track, but a cylinder goes down the stack. So cylinder 1 sector 63 is the 63rd sector on the first track the whole way down. Well, unless you address the head. But basically, these platters are aligned within a very, well, no, they're aligned perfectly, because once they're put in, the disc is then given its low-level information. So these are aligned perfectly. You move it the tiniest possible amount, it's dead. Basically, if you got a dead motor bearing, your best bet is to try and remove it with the spindle still attached. I've seen tools for doing it. They're a bit expensive. I'd love one. A few times I've needed to repair a disc. Obviously, read once, because this is not a clean room. I don't think you could get any further from clean room than here, short of a construction site. But yeah, if you're trying to recover data, never ever remove platters from a multi-platter disc. If it's a single platter disc, you might get away with it. It's not going to tolerate fingerprints all too well, but they read from the out in. Some read from the inside out. It really depends. Yeah. Anyway, I will finish disassembling this disc. So now we have a large collection of parts. Just as a side note, this was an Enterprise class drive, so there's a couple of things that are probably not standard in there. Main casing, along with spindle motor, which I cannot remove. Not without a large punch anyway. Platters, so as I said, there's, whoops, oh look, if it wasn't already broken, it's broken now. Platters, there's 4 of them, so 8 read ride heads, which is interesting, 8 read ride heads, but it's a SATA disc, it doesn't come with cylinder head sector, but it'll be 16,383, 16 heads, 63 sectors per track. There's a limit to the numbers there. I'll come to that one a bit later as well. Head retainer, and also, so one end's got a little magnet that this clips against to retain the heads on the inside. It's also got an overrun protection to stop the voice coil throwing the heads off the side of the disc and making a huge mess. Disc itself with the voice coil. This was a remarkable piece of technology when it came out. And certainly beat the old servo motors. For starters, they were no longer heat sensitive. Older stepper motor discs, you'd have to low level format every so often because the sector would move from where the stepper motor had it. The bottom half of the voice coil magnet, the top half kind of put out of the way. Tried to put my hand out of the way at the same time. The rings for separating each platter, the bracket on top, and I have a feeling that these have to do with airflow. I may be completely wrong there, but I've got a feeling they're to do with airflow, and they went in between each platter in this little stack. Honestly, I've never seen them before. I only surmise they have something to do with airflow. And the main logic board. Which brings me to problem solving for hard drives you just don't do it number 2. And that is, I've heard it said, just swap out the logic board. Unfortunately doesn't work, not on modern drives. So you've got your cache here, main disk controller. What are you? You'll be probably disk controller. One of these is disk controller, one of these is SATA. And smooth. Now, on this as well, it has some non-volatile memory, and basically put into that non-volatile memory when the disk is manufactured is its calibration data. Every disk is different, and on all disks there are some inherent bad sectors. They're not perfect. They never have been perfect. They're getting better, but they're not perfect. So calibration and bad sector data is put onto these boards, which are then paired to the disk. So what happens when you switch boards is you get a horrible clunking noise out of the disk, as the calibration is so far off that it simply cannot do it. Right, I will tidy up this bench and we'll get into the data storage component of it. Okay, I'm hoping this one works. We're about to find out. Gonna draw pretty pictures all over this platter. So back in the days of the original MFM drives, modified frequency modulation, sort of like FM radio, but not really. And even the floppy disks to this day, a platter, or a side of a disk, I do apologise, these aren't going to be very good circles, and I may just have to bring up a... Whoops. Good thing that wasn't glass. This really isn't the best picture, I do apologise. I don't even know if the camera can see this. Let me just check. Oh, it can. Sweet. So originally it was divided up sort of like this. It was an even number of sectors going outward on the disk. As you can probably see here, the issue with that is that the sectors on the outside are huge, and the sectors on the inside are not. If I could think of a better way to do this, I would. So essentially, you're kind of limited for space. So what was brought out after the first of the IDE drives? So this is when cylinder head sector made sense, because your cylinder was your track, so which track, your head, which was which side of the platter, and your sector, which was which sector in that track on that head. Made sense. They mapped 1 to 1. So a disc with, the very early discs, 100 cylinders, 4 heads, and 38 sectors a track. Had 38 sectors. I forgot my numbers. But yes. Then with, mainly when IDE drives first came out this concept of zone bit recording. Basically, instead of this nice neat number, you'd then have extra zones. I mean, this isn't going to look very even because my drawing skills are pretty bad. I have to find myself an artiste. So essentially, you'd have the... Whoops. Close enough. You'd have these zones. I'll just draw a few more along here. My apologies for my terrible, terrible drawing. I think as I go along, I will get better at these things. For those who are new, I'm still very much learning this. Anyway, so what happens with zone bit recording is the number of sectors per track changes. The further out on the disc you go, the more sectors there are. So few on the inside, more on the outside, but they're about the same size. Obviously, as the head goes out, the head doesn't get bigger. It's the same size. So it was very sensible. It came out with IDE drives. So you could jam more data on a disc. I mean, if you stuck with very few sectors per track and all of them the same, then you'd run into this issue that you would eventually run out of sectors. So what happened with the very first discs was you would request a cylinder head sector of an arbitrary number, because at that point IDE drives, you may notice, if anyone actually knows of an IDE drive with 16,000 physical heads, let me know. I really want to see it. I think that would be cool. Not reliable, but cool. You would feed it a cylinder head sector value, and it would then calculate out, well, that's actually here, or there. Basically to keep the old system working and using the new system of data storage. Yes. I'll see if I can draw up a neater one. Hang on. See what I can do. That's probably about the best I can achieve. Next time I'll probably use the computer to draw pretty pictures. Drawing pretty pictures is not my forte. Making computers draw pretty pictures is a little bit easier for me. Anyway, this was... I'm about to lose another platter. This was the new way. Now again, even newer disks use 2 kilobyte sectors instead of 512 byte sectors. If you're dealing with a lot of small files, that's not good, but files these days are getting a lot bigger, so you're not really going to notice that. And look, with the transfer speeds of modern hardware, it's just much better. 2K blocks will transfer far quicker than 512 byte blocks, and SSDs, and all modern, all very modern. Now, within the sectors on the disk, on an IDE drive, because the voice coil doesn't know where it is, it needs feedback. Servos used to be able to step back to 0 and figure themselves out. IDEs can't. So basically embedded in the information on the disk is servo information saying where it is on the disk, basically what track it's at. That used to be dedicated to a whole platter. One whole platter on disks used to simply contain servo feedback information. Newer disks, it's embedded along with all the other sector and error correcting data and your data. It's a lot more complicated. The very first, so ST504 disks could be low level formatted. IDE disks can't because of the precision which with that indexing information is put on. You can't write it again. If it goes away, it's gone. Which proved problematic for the owners of compacts, which had the very first IDE disks, which honoured low-level format, would then blow away the index data from the disk, and voila, paperweight. They very quickly removed the turn disk into paperweight feature. Very quickly. Yeah, so that's basically how it's all lined up. I'll see if I can find something on the internet with an image of how a single disk sector is laid out on disk. Right, so I found an image on Seagate's website with sector layouts. Now these are for the 512 byte sectors, but they count just as much for the advanced format sectors. My apologies, by the way, they're 4K sectors, not 2K sectors. May have dropped the ball there. It's not often I forget these random details. Anyway, so let me just bring that up. So basically the sectors are laid out with a gap, which is just nothing, just to space them apart slightly. Synchronizing mark to synchronize all the clock circuitry. Clocks drift, they need something to sync them. The address mark, which is what tells the stepper motor where it's at. The data that's stored in that sector, 512 bytes of whatever. Generally, you know, the cluster size on a disk is bigger than 512 bytes. So, you know, a single cluster might take up 4 of these sectors if they're 2K clusters. And then an error correcting code at the end, which tends to quietly correct errors. There are more disk errors than you'd think, but most of them are correctable. The uncorrectable errors are very rare. Actually, I think it's 1 bit in 1 bit in several terabytes. I'll have to look that one up. I'll look that up, hang on. Let's have a look. I can't type. Hopefully this tells me what I want. No, there is a value in there called basically the uncorrectable error count. Maybe this will have some numbers. Numbers are nice. That disc has chicken pox. I think I know what's wrong with that one. Reallocated sectors are when sectors get moved elsewhere on the disc. This sector is now over there. That just means it's dying horribly. Uncorrectable error count when a sector's so bad it can't be read for read mapping. That basically means a sector that's toast and it couldn't move the sector. It's time for a new disc. Very time for a new disc. The rate is 1 bit in several terabytes. Unfortunately, they need to improve that now that discs are several terabytes. It increases the chance of a failure. It's almost the top. It's slightly out of calibration. There we go. Yeah, I've probably talked for long enough about hard drives. I may even have forgotten things, but see how we do. Anyway, thanks for watching.